Okay, class, we're on 4.5, write equations of parallel and perpendicular lines. This starts in your book on page 258. So we're going to start with our vocabulary of parallel and perpendicular, and I think we all know the definitions of parallel. Two lines running along that will never touch, never intersect, never touch. I want to introduce the symbol we use. So the symbol for parallel, instead of having to write parallel over and over again, looks like this, okay? And perpendicular, two lines that intersect forming 90-degree angles, our symbol looks like this. For writing equations, parallel has the same slope and perpendicular have the negative reciprocal. And I'm going to try and spell it correctly. I misspell it way too often. So I'm going to give you an example. Y equals 6x plus 2. My slope is 6. My parallel slope would be 6, the same. My perpendicular slope, the reciprocal, which is a word we've used previously, one of our previous vocabulary words, means flipping it upside down. So instead of 6 over 1, it becomes 1 over 6. And it has to have the opposite sign, which in this case would be negative. Okay, moving along. Our goal today is to write equations of parallel and perpendicular lines. Okay, moving along. This goes along with what's in your book. It's example 1. It starts on the bottom of page 258. 259. Take a look at those pages. You noticed I've used my fancy pen here to remind everybody that we are writing in slope-intercept form. Y equals mx plus b. Remember, we can't identify the slope or the y-intercept until it is in this form. So taking a look, the directions say write an equation of a line that passes through the point negative 2, 11, and is parallel to the line y equals negative 1x plus 5. So let's start with y equals negative 1x plus 5. My slope in this equation would be negative 1. The key word here is parallel. Parallel. So if it's parallel, I'm looking for the parallel slope. And we just went over the parallel slope is the same. So my parallel slope would be negative 1. So now I'm back to what we were doing previously. I have this equation, y equals mx plus b, slope-intercept form. I also have a point. My point here is negative 2, 11. We should remember x comma y. And I now know that the slope, the parallel slope, is going to be negative 1. Using this information, 11 goes in for y, negative 1 goes in for m, our slope, negative 2 goes in for x, and we're trying to find our y-intercept. So 11 equals negative 1 times negative 2 is 2 plus b, subtract 2. So I get a value of 9 for b, okay? Once I have that value, I'm going back to the directions here. It says write an equation. So I'm not done until I take my information, and in this case, this and this, and write my equation. So y equals mx plus b, y equals negative 1x plus 9. So multi-steps, got to keep track of them all. In this instance, they're asking us, is line A perpendicular to line B? Justify your answer. I want to talk about justify. Justify means explain, show a reason. You can't just say A and B are parallel because it looks like they're parallel, or A and B are perpendicular because they look perpendicular. We have to, if it's talking perpendicular, prove it, and the easiest way to prove it is by using the slope. So I'm going to work over here on line A. Okay, and I have 2y plus x equals negative 12. Remember, I don't have it here in my fancy pen, but this is what we're going for, slope-intercept form. So I need to subtract x from both sides. I end up with 2y equals negative x minus 12. Divide everything by 2. Y equals negative 1/2 x. Negative 12 divided by 2 would be minus 6. So now I need to look at line B. I have 2y equals 3x minus 8. Have to divide everything by 2. These cancel, so I end up with y equals 3 halves x minus 4. Negative 8 divided by 2 is negative 4. So are they perpendicular? If I look at my slope here and my slope here, are they negative reciprocals of each other? And the answer is no. And the reason is the slopes are not negative reciprocals. There is an R in there. Any questions on this one? So moving on. This example, and again, highlighters are a good thing to use, talks about perpendicular, writing an equation of a line that goes through this point and is perpendicular. So I'm going to start with my first step, write the equation 4x minus 7. Can I identify my slope? And I can. The slope is 4 over 1. My perpendicular slope would be the negative reciprocal. Flip it upside down. Use the negative sign. Using this information, I have my slope and I have my coordinate point. I need to write the equation of the line. So y equals mx plus b. I have to find my y-intercept. 3 goes in for y. Negative 1/4 goes in for my slope. 4 goes in for my x plus b because I'm trying to find b. 3 equals negative 4 times 1, multiply straight across is negative 4. 4 times 1 is 4 plus b. 3 equals negative 1 plus b. Add 1 to both sides. 4 equals b. So now I have identified my slope and my y-intercept. I can take that information and write the equation of the line that goes through point 43 and is perpendicular to y equals 4x minus 7. Negative 1/4 x for my slope plus 4 for my y-intercept. Okay, and finally I have a reminder here in my big fancy pen, so hopefully we all get it. If the directions are not specific, your answer must be in slope-intercept form, which is y equals mx plus b. Remember, before you can identify the slope, before you can identify the y-intercept, it must be in y equals mx plus b. Not negative y, not 6y, y equals mx plus b.